Welcome. In this video, we are going to discuss the normal approximation to binomial distribution. What is it? Okay, when we deal with, this is one of the limit theorems that is available in statistics through which we are performing all these things. Suppose x is a binomial random variable with parameters n and p. Okay, usually random variables are described using two parameters, namely the number of trials and the probability of success. Okay, and we know that the mean in binomial random variable is np and variance is npq. So if we just do the calculations and we just normalize it, okay, so we convert it to a standard normal variate. Now through normal approximation we are going to calculate the required probability. This would be good if n is large quantity and p is near 0.5. Okay, and any random variable can be normalized, okay, standard normalized, but still if your discrete random variable is approximated as a normal variate, notice that normal is a continuous variable, the continuous variate, whereas binomial is a discrete variate. So we will have to be careful with the continuity corrections, and that is given in this slide. So this event, the probability that x takes the value k is considered as this interval. So whenever you have x smaller than or equals k, which is occurring in your probability calculation, you will have to convert this to as x smaller than k plus half. If you have x less than k, it should be treated as x less than k minus half. So this is how you will have to make the calculations when you convert your binomial variate into a normal variate. Okay, moving further, we have a problem. Okay, like even if for this problems I'm just going to give you the hints. Remember, okay, here the problem is a fair coin is tossed 100 times. What is the probability that the number of heads is between 35 and 65? We are asked to use normal approximation. So your n is 100 here. Okay, you are tossing a coin. Okay, number of heads. So the probability is what? Half. Okay, mean is np, that is 100 times of half, which is 50. Okay, variance is npq, so 100 times of half, and q is also half, which is 25, which tells you that your sigma is 5. Right? You are asked to calculate the probability that the number of heads appearing is between 35 and 65. Okay, so what we are going to do, we will convert this into 35 minus your mu value is 50 upon 5 smaller than or equals, this becomes a standard normal variate, 65 minus 50 upon 5. So what you actually have is minus 15. So it would be 3 less than minus 3 less than or equals z less than or equals 3. So this can be treated as 2 times of probability of 0 less than or z less than or equals 3, since we are going to make use of one-sided table. And remember, we have converted the binomial variate into a normal variate, so we'll have to make use of continuity correction. So that gives us probability of from 0 to less than, how do we change it, less than 3 plus half. So what you have to do is 2 times of probability of 0 less than or equals z less than or equals, less than 3.5. You just find out this value from the table and this is the required probability. Okay, now moving further, in the next problem, in an objective test there are 75 problems with 4 options each, and only one option is correct. If a student answers all the problems by randomly selecting an option, what is the probability that he can get more than 25 correct answers? Okay, so here n is 75 and the probability of success, there are 4 options and only one is correct. He is choosing the answers in random way, so out of 4 only one can be right, therefore our q is 3 upon 4. Okay, what is your mu? Your np. Okay, and sigma square is npq. Okay, from which we will calculate sigma as under root of npq, and we are asked to calculate the probability that more than 25 answers, so greater than 25, this is what we have. Okay, so this one we will write it as x minus mu upon sigma greater than 25 minus mu upon sigma. So this one, how do we interpret? 1 minus probability of z less than or equals 25 minus mu upon sigma, isn't it? And remember, we have less than or equal to, since we are converting the binomial case into a normal thing, you will have to make use of the continuity correction by adding 0.5 to this and convert it as probability of z less than whatever the quantity that you get here plus 0.5. Okay, now that you need to read the values from the table and calculate the probability. That's it. And the next problem tells us the probability that the electric component fails is less than 100 hours of continuous use is 0.25. Okay, that is, if you are continuously using the electrical component for 1000 hours, the probability is 0.25. Use the normal approximation to find the probability that among 200 such components, fewer than 45 will fail in less than 1000 hours of continuous use. So now that you don't have to worry too much about this 1000 hours, here the probability of failure. Okay, so we are interested actually in calculating the probability of failure. So P is 0.25, therefore your Q should be 0.75 and your N is what? We have 200 such components. Okay, and we are asked to calculate the probability that fewer than 45 components failing. So this is what we need to calculate. Okay, calculate your NP and NPQ, that is your mu and sigma square. Just like the previous problem, you just do the calculations here and find out the value. Remember, here we have less than. So when we make when we convert this to a normal variate, so this is what we would have. There we added 0.5. Here what should we do? We will have to subtract 0.5 and find the probability. Read the values from the table and find the probability. That's it. Thank you.